This is a lesson on the relationship between sines and cosines of complementary angles. I think this is the next lesson you have coming up. So here you have a right triangle, so that means we're able to use our sine, cosine, and tangent rules. So remember, sine of an angle is equal to the ratio of its opposite side to its hypotenuse. Cosine of an angle is equal to the ratio of its adjacent side to the hypotenuse. And tangent of an angle is equal to the ratio of its opposite side to its adjacent side. So here, when this question is asking you to fill in these values here, you're using this triangle. So sine x, so this is x, sine of x is equal to opposite, so opposite, over hypotenuse. And remember, hypotenuse is always opposite the right angle. So that would be x over z. So that's sine of x. Sine of y is equal to, so now we go to this angle. So opposite this angle is y. So sine of y is equal to y opposite over hypotenuse, which is still z. So let's say you had to find the cosine of x. Cosine of x, so this x here would be equivalent to its adjacent, so adjacent y over hypotenuse, still z. And cosine of y, that's y, would be equal to adjacent x over hypotenuse. So these are, this is kind of showing you the relationship between complementary angles, because you can see here the sine of x is the same exact thing as the cosine of y. And the sine of y gives you the same thing as the cosine of x. And that's because these are complementary angles. And complementary angles, it just means that if you were to add these two angles together, you would get 90. All right, so this problem is asking you to prove the law of cosines, but it's taking you through it step by step. So it says, first step is use the Pythagorean theorem to find c squared. So we want to go to this triangle here, and I'm actually going to make that just a little bit bigger. There we go. So I'm going to go to this triangle here, and we're going to solve for c squared. So I'm using this right triangle right here. Sorry, lines are a little sketchy, but that's okay. So remember Pythagorean theorem, c squared is equal to this side squared, so a squared plus, or sorry, that's an x squared plus h squared. So let's erase that just so we can see it a little bit better. But you can see this side right here is x, and that's h. So c squared, that's our hypotenuse, is equal to the sum of the other two sides squared. So there's that first part. Then it says use the Pythagorean theorem to find b squared. Okay, so that's this part right here. So b is also the hypotenuse of this right triangle, because we're using this right triangle this time. Okay, so b squared is equal to h squared plus, well, this whole thing is a, and this little piece is x. So that means this side has to be a minus this bit of x. So a minus x. So we're still following the Pythagorean theorem though. B squared is equal to h squared, that side squared, plus a minus x squared. So that gives us a minus x squared plus h squared. Okay, so part 3 wants us to use the answer from part 2 to fill in these blanks. So b squared is equal to x squared plus h squared. And what we need to do now is go ahead and expand a minus x squared. Okay, so let's go ahead and expand this. So we're going to expand this using FOIL. So that's a minus x times a minus x. So a times a is a squared. A times negative x is negative ax. A times negative x is negative ax. Negative x times negative x is positive x squared. And then we still have this h squared. So notice these are like terms. So that becomes h squared plus a squared minus 2ax plus x squared. So now we want to fill in the blanks using this. So we already have the x squared, so that's out of the way. We already have the h squared, that's out of the way. So what we're missing is a squared here, so that becomes an a, and negative 2ax. So that fills in part 3. All right, so for this next step, which is part 4, we need to use parts 1 and 3 to fill this in. So part 1 tells us that c squared equals x squared plus h squared. And remember, our ultimate goal is to prove the law of cosines, which is c squared equals a squared plus b squared minus 2ab times the cosine of c. So that means when it's all said and done, we want things in terms of just a and b. So at this step here, step 3, we have things in terms of b, x, and h and a. So b squared, I'm going to just rewrite that again, is h squared plus a squared minus 2ax. So from this point, what we want to do is go ahead and substitute for h squared. So h squared, if we were to solve this for h squared, we would get c squared minus x squared. So for h squared, I'm going to plug in a c squared minus x squared. Okay, well, here you can see that you have an x squared and a negative x squared. So that gives us b squared equals c squared plus a squared minus 2ax. So we're looking pretty close to this formula. Not quite there, but pretty close. Because these variables are interchangeable. The most important thing is that this side is opposite this angle. So what we don't have is cosine. So this next step is asking us to solve for x in terms of cosine. So we're going to go back to our triangle here. And we see we have a cosine b. So let's use our rule for cosine. Cosine b is equal to opposite over hypotenuse. So that's going to give us cosine b, cosine b is equal to adjacent over hypotenuse. That actually makes our lives easier there. Adjacent over hypotenuse. So that's going to give us, so x is equal to, I'm going to get x by itself, multiply both sides by c. So x is equal to c times the cosine of b. So when I substitute that in, I get b squared equals c squared plus a squared minus 2 times a. And then instead of x, I'm going to substitute in c cosine